All right. So welcome to today's session. Essentially, I'll be talking on a very high level about architecting Oracle workloads from on-premises to the VMware Hybrid Clouds. I'll tell you guys a story. Essentially, how we move from, let's say, the big Endian systems, right? That could be your AIX, Solaris, HPUX, engineered systems, commodity x86, or even another virtualization platform over to VMware. I'll talk a bit on a high level on best practices, what things you have to keep in mind. What options do you have when you have to go to the cloud? What are the things that you have to keep in mind when you have to go to the cloud, right? So given that this session is only 25 minutes, I won't be able to go into much detail, but after that, I will be available at the booth, the Explore floor. Feel free, come talk to me, right? More than happy to talk to you guys, but let's get started. So essentially, like I said, I'll start about talking with migrating Oracle workloads to platform, the best practices, talk a bit on VMC, VMware Cloud and AWS, deployment migration, business continuity, disaster recovery. I'll touch also on the VMware Cloud Flex Storage. That's the offering that we give to customers when they go to VMC for a reason that storage is limited when you have vSAN for tier 1 for production databases, right? And how does the Flex storage help you, especially with archive log, backup, and let's say tier 2 databases on VMC, right? But this is a slide I've been using for the last, 12 years. So my background being doing databases for 26 years, Oracle. I started with Oracle 6, came to VMware 2012, and I've been doing Oracle on workload on VMware for the last 12 years, right? But I've been using this for the last 12 years just to stress a point or send a point home that if you have any business critical application, right, that could be the Oracles of the world, SQLs, your SAPs, Java, so on and so forth, every application has stringent requirements, right? Availability, performance, security, so on and so forth. How many times did you ever have to go in the past couple of years to the IT department and basically say, I need a new socket board, I need new memory, I need more storage, right? And they said, okay, you know what, fill out this requisition form, come back and talk to me 15 days from now, you'll have your stuff, right? That doesn't fly in this world, that doesn't fly. You need to have the hot add CPU, hot add memory, hot add devices, correct? On the fly, because you have to scale up, scale out, right? You need to scale up horizontally, scale vertically as well. So these are some of the requirements, if not all, of business critical applications. The methodology, right? Again, this is a slide which is very old, older than me as well, right? And I'm a very old guy. This again, for a reason why. See, when you start looking at the top, where you start gathering requirements, you go sell the project to stakeholders because you need money as well, right? To get the project done. You make sure that you understand the constraints of the environment. DB workload measurement, and I'll touch a bit on the DB workload measurement. You start migrating your databases, licensing, best practices, backup recovery, HA, DR, monitoring and tuning. Can anybody in the audience please tell me if this is something that I need to do specifically for VMware? Nope. This has got nothing to do with VMware. I would basically do the same thing if I'm moving from, let's say, one set of x86 server to another set of x86 server, right? A replatforming, a refactoring exercise. If I'm moving from, let's say, Exadata over to x86, I would do the same thing. If I'm moving from OVM to VMware, I would do the same thing. So nothing changes from an Oracle perspective when you virtualize your Oracle workloads on a VMware vSphere platform, be that on-prem, be that hybrid, or be that to the cloud. See, what happens is typically when you embark on this journey to virtualize your Oracle workloads, right? Then there comes a fork in the road where you have to measure your workloads, right? And then you have two choices. Should I just pick everything, what's here, and throw it there, which means from physical to virtual? You could do that if you want to, right? Or should I actually invest some time, right, and look at what my workload sizing is? There are pros and cons to every approach in life, right? With the approach on the left-hand side, that's the fastest, trust me. Your use case here is your boss basically said, you have 15 days or you have a month, you got to move everything from physical over to VMware and you don't have time, right? What you would do, you would say, well, this server is 2-socket, 10 cores, which means it's got 20 cores. I think this virtual machine needs 20 vCPUs or 40 vCPUs, right? All it did was you stuck a finger up in the air, you picked a number, you threw it on the virtual machine. You moved your stuff. 6 months from now, you look at VROps and you come back and say, wow, I bought 1,000 servers. I don't even need 600 servers. What do I do with that? You see what I'm saying? So that's the cons with that approach. When you start looking at workload sizing, you have a very good idea, right, what the beast looks like. Because see, you have to understand the nature of the beast if you want to control it. In this case, it's the Oracle databases, right? So your workload profile, and I'll show you how to do that, right? But essentially, let me see if I have that here. let's go back here. See, what happens is from a very high level, if you were to ask me this question, okay, that's great. You spoke about workload profile measurement, right? For Oracle databases. How do I do that? There are two ways to do it. If you don't have the essence of time, one could use what's known as live optics. How many guys have heard of live optics? DPAC, live optics, right? It's a great tool. It's an agent-based tool where you deploy the agent and say, you know what, you agents, you processes, go sit on these target servers, physical or virtual, and what it does, it starts collecting statistics on CPU, memory, disk, and network, right? It collects stats. How often should I collect those stats, or how frequent should I do that? Should I do it on a Sunday or a Saturday? No, you don't do that on Sunday and Saturday. You basically go back to the business and say, you know what is your business peak processing time? They say, well, Monday to Friday. Well, within that peak processing time, which time do you think is the most important? They'll come back and say 9 to 11. I'm making this whole thing up, right? 9 to 11. What you would then do, run live optics Monday to Friday, 9 to 11 or 9 to 12 for 2 weeks, 3 weeks, 4 weeks, and then it comes back. And you know what you get? You get a quadrant, CPU, memory, disk, and network, the approximation, right? Now, based on that, you go back, you design your virtual machine. That's your straw man. Once you do that, you migrate your workloads from physical to virtual, you test it. So that's called the approximation way of doing it. Some of you may just stand up and say, well, you know, I have the essence of time of doing it. Tell me the right way to do it. The right way is essentially to look at 3 metrics, or I would say 3 tools. 1, Specint. How many people have heard of Specint? Spec.org. Excellent. Spec.org basically says this class of servers correspond to what class of servers here, right? It gives you a very good feel. See, I don't know the number of people who's going to come and sit in the room here, but I know probably 20 chairs, right? That's good. Then I'll start looking at the number of people coming in. Then I'll know the number of servers. Similarly, Specint tells you you need these class of servers, but I don't know how many. Then you start looking at the physical workloads. You start looking at the operating system, right? You guys are Linux guys, right? You would look at the system activity report, SAR reports. The SAR report would say 60% CPU, 80% memory, so much of disk, so much of network, right? You would then come up with a virtual machine. But the real design comes from the database. When you start looking at the database, the DBA would come back and say, I ran something what's called the Oracle AWR. How many people know what AWR is? Yes, AWR stands for Automatic Workload Repository. Just like in the Linux world, Linux takes snapshot of itself, right? Linux system, when you set up systat, right? Or perfmon, it'll take snapshot of itself at every predetermined interval, 10 minutes by default. An Oracle database by default takes snapshots of itself, the database activity, every 1 hour. So what will happen is the DBA would come back to you and say, you know what, this is the amount of IOPS, this is the amount of CPU, so much memory, so much of network. That's all you're looking for, correct? And once you have those numbers, you design your virtual machine based on best practices. You will not stick a finger up in the air and basically say, I need 1 vCPU or I need 3. No, you would use these parameters. You would use these tools to tell you what the number of vCPU, memory, disk, and network is. And then I also spoke about the migration, right? So essentially, remember, all road leads to Rome here, right? In this case, either you're moving from the big Endian systems. How many people have heard of big Endian systems? That's your AIX, Solaris, HP, UX of the world, right? See, remember, when you run your databases on big Endian systems, you can't suck the data from here and spit it out here. It doesn't work that way. It doesn't. You just can't do a CP minus RP, SCP. It doesn't work that way. You got to use the Oracle way of sucking data, changing the block, and dumping it, because the big Endian systems, which are the AIX, HP, UX, Solaris of the world, the block format is different. The x86, the block format is different. So whether you come from here, whether you come from Exadata, which is an x86, a little Endian system, or whether you come from any of the other virtualization platform, you will land on the VMware vSphere side. And once you do that, best practices, this is where the ball stops. You know, the ball stops here. Best practices. My background I've been doing services, professional services for 3.5 years before I moved to tech marketing and global technology services, right? There has been so many times when I walked into a customer shop and I see vCPUs 13579, and I asked the guy, were you dreaming yesterday night when you picked the number up? What were you thinking? Why did you pick a vCPU as 13579? His or her answer is, I don't know. That's not how you do it. You have to keep NUMA in mind, correct? Because there are 4 levels of NUMA. There are 4 levels of NUMA. Hardware, ESXi, guest operating system, virtual machine, the database. 5. I lied, there are 5 levels. So you have to keep all those 5 levels of NUMA in mind. Memory reservation, making sure that your queue depth is set for your VMDK and also for your PV-SCSI adapters. Why do I have to worry about that? I don't care, right? Let me ask you, how many people here in the room have basically gone out to the market to buy a server with 1 HBA and 1 port in the HBA and basically said, I have it, I have a single point of failure? How many people have done that? Nobody would do that in his or her real mind. Same thing up here, because queues, right? Load balancing, fairness, queue depth. That's why VMDK queue depth, PV-SCSI queue depth, I/O scheduling on the guest operating system, setting the right I/O scheduler, NUMA, memory reservation. When you do all of that, then when you run a load test, then you can go back and see, well, I came up with this straw man. Was the design good or was the design bad, right? You just can't, what I'm trying to say here is you have to treat the virtualization environment the same way as you would do with the physical environment here as well. The link at the bottom of the slide basically goes into all of the best practices. We don't have much time to go through it. We used to have sessions before in VMworld where I used to run like a 3-hour or a 4-hour best practices session where we used to go through every parameter, every best practices. Unfortunately, we don't have that essence of time, but if you wish to discuss that, I will be available to talk about it. But moving on, this is what everybody wants here, right? Everybody's here for the cloud. For myriad of reasons, for many reasons. They say, you know what, I want to move to the cloud, but I want to have best of both the worlds. See, I don't want to relearn any new tools. I don't want to, go on to a new architecture. My guys have been doing VMware for so many years. I don't want to erode their skill sets. How can I have the cloud? How can I have VMware, right? And have the cake and eat it too? How can I do that? That's what you want, the VMware Hybrid Cloud. So we essentially partnered with pretty much every hyperscaler, right? So we have VMware Cloud on AWS, Google Cloud VMware Engine, Azure VMware Solutions, right? We have AVS, we have IBM Software and Alibaba as well. So if you go to the Expo booth, you will have every flavor of VMware Cloud with pretty much every hyperscaler out there. You have SMEs that you can talk to, right? But the best part is by using the VMware flavor both on-prem and the cloud, you solve the most important problem, and that is you reduce refactoring and replatforming. Think of it. Your on-prem is OVA, right? If you have to move to AWS EC2, what is that? AMI. If you have to move from EC2 or AMI to OVA and back, what do? You got to change a virtual machine format, right? You got to create a new virtual machine, port the data, blah, 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 blah. What happens? That is a breach in your SLAs. That is downtime for your application. What if I tell you on-prem VMware, in the cloud, it's VMware, you have a direct connect, or let's say you have a L2 VPN, move it to the cloud, move it back. And your use cases could be data center extension, data center expansion. I want to onboard a new customer. I want to burst to the cloud, pretty much all of that, right? So you are not changing anything from a customer perspective here. That's life of an Oracle DBA, right? If you think the life of an Oracle DBA stops here, you guys are mistaken. Because right now, you just added the complexity of a cloud. So now we have to look at the cloud as well, right? The same thing happens in the cloud. So I spoke about the extension, disaster recovery, and the cloud migration use cases here. But I'm going to talk about VMC today, the VMware Cloud on AWS, right? So you guys have heard of this proposition, right? We had i3, we had i3EN, and now we have i4i. I'm not going to go into the details of the number of socket, number of cores. Those spec sheets are available at the different booths. But the best part here is if you have a direct connect running from your on-prem to the cloud, you save your refactoring, your replatforming, and trust me, that takes 90% of your time, right? See, think of it. For a moment, remove your infrastructure hat. Think like an Oracle DBA, right? If my SLA is 9 nines or 5 nines, right, or 4 nines, right, and my ask is to move to the cloud, my first thing is, you know what? If you don't give me a direct connect, or you don't stretch the layer 2 network from on-prem to the cloud, I'm not going. You can do whatever you want. I'm not going. So you as a CIO or you as a director of data center engineering, you guys have to provide that capability for the Oracle DBAs or the SQL DBAs or the MongoDB DBAs to do that. So we have 2 use cases here, deploying workloads and migrating workloads. And the reason why we're doing that is because I want to see, is there anything different I would do in the cloud than what I would do on-prem, right? So in the cloud on VMC, what we did was we deployed an Oracle workload, a single instance Oracle workload, a non-rack, right? You would do the same thing. You have a VMware template, you would clone from the VMware template, you would assign IP addresses to that, the DNS, the net masks, blah, 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 everything is exactly the same. It comes up, there is no difference. Because remember, it's VMware here, it's VMware there in the cloud. So from a deployment perspective, if you guys are looking to burst to the cloud, there is no difference from your perspective. You start looking at Oracle migration. Well, I need to migrate my Oracle workloads, my existing Oracle workloads, from on-premises to the cloud because my DC, my data center, is shutting down. My boss just said, move everything to the cloud. I gotta move. How do I move? There are many ways you could move, correct? And most of that depends upon what are my SLAs, what are my RTOs, what are my RPOs, right? But essentially, on a high level, you could do that in two ways. Either using the Oracle native tools, right? You guessed it right. I could use Oracle Data Guard. You guys are familiar with Data Guard, right? That's the Oracle-based replication. Data Guard from on-prem to the cloud. When everything is synced up, you cut the umbilical cord. You basically said, that's it. That's the primary. I'm done here, right? That's one way to do it. Take a backup, take it to the cloud, do that as well. So that's the Oracle way of doing it. But remember, you got to pay the piper, right? Those are expensive. It's not easy. It's not cheap, right? From a VMware perspective, and I'm sure you guys have heard of Hybrid Cloud extension, right? HCX. I'm sure. VMware HCX. So once you have HCX enabled, right, you're then able to move or migrate your Oracle workloads from on-prem to the cloud using HCX, and you have various flavors of HCX here, right? But the one that I love very much is what's called the RAV, the replication assisted vMotion. You know why? There is no downtime. What happens is it happens in two steps. There's bulk replication that happens from on-prem to the cloud, right? So while we are speaking, there's replication happening from on-prem to the cloud, and when the delta is far or very, very near zero, that's when the context shifts. It's like a vMotion. How does vMotion happen, right? vMotion doesn't say, okay, all the applications stop, let me vMotion it and then come back and talk to me. It doesn't do that, right? It syncs everything, it replicates everything, and when it's time, there's a brief stun moment, the context area gets shifted, right? The memory gets copied. That's what RAV is. So for Oracle workloads, for SQL workloads, which are tier 1, if you have a direct connect, if you have layer 2 VPN, absolutely. You could use RAV, but that doesn't mean that the other ones don't work. Yes, it does. Your cold migration could be your dev, your test, your QA. Who cares, right? But for the production, consider the RAV, right? And that's what we will be looking in the forthcoming slides here, right? It's very easy. Once you have HCX set up, once you add the Oracle virtual machine to the migration process, you select the compute storage pool, right? And I don't know if the guys in the back can see that. You select the destination folder because VM and folders, you got to pick the right folder. You pick the correct data store, and that's it. You say go. I mean, I don't think there's anything more simpler than this, right? You pick the compute, pick the resource pool, you pick the data store when all the mappings are done from an HCX perspective, and you click, and you say submit, and done. And let's say, if you have to come back, you would just do the reverse. But here's the thing, hang on. The proof lies in the pudding, right? How can you tell me that the migration was successful? If somebody were to ask you, how can you tell me, how can you guarantee the migration is successful? Every Oracle database has something what's called the Oracle alert log file. Just like you have var log messages on Linux, a database has alert log file. Look at the alert log file. Everything good, bad, and ugly is there in the alert log file. When we did that, we found there was no crashes. It didn't say, oh, oops, I'm going to crash right now, and then you need to recover me. Nothing. It just came up. It was up and running on premises. All I did was an RAV to the cloud. When it went to the cloud, there was no blimp on the radar, if I could say that. There was no blimp on the radar, right? And let's say if I have to come back, I would just do the reverse steps here. Select the compute pool, select the data store, select the folders, and I'm back on-prem, right? If I have to bring everything together, you know what? Business continuity, disaster recovery, on-prem to the cloud, the way that I would read it is this way. Start from the middle, right? When you look at on-premises, see, remember, any operation can happen at 3 different levels. 3 different levels. The application level, vSphere level or the platform level, and the storage level, right? App, platform, storage. When you look at the app level, any business continuity, you could do using Oracle RMAN, right? Oracle backup, Oracle data pump, anything. Oracle export, import, everything works as a charm, right? When you come down to the VMware vSphere level, snapshot, clones, it works as well. When you go down to the storage level, you have storage-based snapshot and storage-based clones, right? Now, when I have to do a on-prem DR from site A to site B, let's say from Barcelona to Madrid, right? This is what I would do. I would either use DataGuard. If I want to go with application-based replication, I would go DataGuard, Golden Gate. If I don't want to do that, I could do SRM, Site Recovery Manager, or vSphere replication, or I could even do Site Recovery Manager with array-based replication, or if you guys, how many guys have heard of vVols, virtual volumes? Right, vVols, definitely. You could also use vVol to do that. So you have a lot of choices, right, with respect to business continuity and DR. If you have to go to the cloud, the same thing. You could use Golden Gate, or you can use DataGuard from an application perspective, or you could use what's known as VSR. VSR is just a marketing term. It's vSphere replication at the end of the day. That's all it is, right? Or you could use VCDR. I'm sure you guys have heard of VCDR as well, right? The most important thing for any replication tool is three words: right order fidelity. Right order fidelity, which means, are the blocks arriving in the correct order? That's important, right? Are the blocks arriving in the correct order? Let me tell you, from an Oracle perspective, all Oracle replication tools guarantee that, of course, because it's an Oracle tool, right? From a VMware perspective, VMware Snapshot, VMware Clones, SRM, vSphere replication, array-based replication, vVol, VSR, VCDR are all right order fidelity. They guarantee that. For example, Snapshot, point in time. It's a point in time, right order fidelity. Your VCDR, it sends your snapshots to the cloud, right? SCFS, your scalar file system, it uses snapshot, point in time, right order fidelity. So that's what you need to figure it out, but that's guaranteed. So this is just another example I wanted to give you. I think I have time. There's another example I want to give you. Like if you have to, let's say, move from a single instance database or an Oracle rack on source, your source could be any of these, right? Could be your engineered system, physical x86, a virtualization platform. Once you land on a VMware vSphere level, I already spoke about the different levels of replication and business continuity, right? One of the use cases here, or one of the restrictions here with Oracle Rack running on-prem is if you guys are using how many guys are running Oracle Rack on-prem? Good. Multi-writer, VMDKs? Are you guys using multi-writer VMDKs, or is it RDM? I don't want to hear RDM, please. No more RDMs. You guys have to move off RDMs to vVols. If not, come talk to me. I'll turn you into believers, right? But what happens is with multi-writer flag and VMDKs, you cannot do vSphere replication, right? There are certain restrictions with that. The KB article is 1034.165. If it's vSAN, it's 212.1181, if my memory serves me right? So in order to get through that or around that, you essentially have to put a single instance database and then you can replicate it, right? But these are some workarounds that we have. Let me show you this. So this is our latest offering, right? The VMware Cloud Flex Storage. And there's a reason why we did that. Because let's say if you have a 3-node, a 4-node, or 5-node, right? The amount of storage is directly proportional to the number of drives that's there in those servers, correct? You automatically cannot put more drives in the server. That's the capacity. That's what you bought. You need another cluster, go buy another cluster. But look at my Oracle databases. They are 10 terabytes, 20 terabytes. Hey, I need to have archive log. I got to do backups, right? And you know, when you look at databases, you have like backup of backups of backups, right? 20 backups. And then I need a backup of QA. Where would you store all these? Where would you store all of that? You don't want to store it on your tier 1 NVMe vSAN. That's where you can store it. Cloud Flex Storage. Now, yes, I can store it. How about the performance? Is that comparable to vSAN? I didn't trust it, so I said, you know what, let me run a couple of tests. And this is what I did. A 4-node VMC cluster, right? i3 Metal. That's the latest Oracle 21C version. 8.7, I know 8.8 is out, even OEL 9 is out, but that's a stable version. All we did was we did 2 test cases, right? This one is for the paranoid Oracle DBAs like me in the back, who basically don't trust anything or anybody. So we said, you know what? No mirroring. I don't like mirroring. No RAID 1, no RAID 5, no RAID 10, no nothing, right? I want to set OSR, object space reservation, to 100%. It's almost like an eager 0 thick, right? So that's one storage policy. The other storage policy was default vSAN. I said, let's run our workload and see, can I stress it and how close does it come to my tier 1 NVMe vSAN storage, right? The test bed I used was SLOB, SLOB. SLOB stands for Silly Little Oracle Benchmark. The only thing it does, it pumps I/O. Boom, 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 boom. That's all it does. Sends I/O down, right? So it's a very I/O intensive workload. Setting the workload unit to 3 drives the most amount of I/O without stressing redo. You don't want log activity. You don't want archiving activity. You want to stress the I/O subsystem. When I did that and we compared the 2 default, the storage policies across the 2 runs here, the vSAN versus the Cloudflex storage, look at the difference. It's single digit. There's a difference of 4%. So if I tell you the difference, the performance difference is 4%, probably one of you will stand up and say, then why do I need vSAN? No. That vSAN NVMe tier 1 is for your tier 1 databases production. But for something that really doesn't need that production tag, you can use the flex storage. You can use it for archive logs. You can use it for backups. You can use it for non-production, right? Your QA, your dev and test, which means you don't have to go out, buy another VMC cluster. You could have the same VMC cluster. You are now able to provide or provision more storage, right? So that's an excellent use case for customers who are in VMC and who have huge databases. Doesn't have to be databases, who have huge applications that requires lot amount of storage here. But if there is anything I want you guys to take away from this session, that's this one link here, where essentially any stuff that we produce, Oracle on VMware, Oracle in the cloud, best practices, things that happen, things that work, things that don't work, technical blog articles, KB articles, important collateral, everything can be found here. If you guys are looking for information as to how one would deploy or migrate Oracle workloads to the cloud and back using all of the mechanisms that I told you, right? HCX, the Oracle native tools, it's there in this guide. Everything is there in this guide, right? But I think we have close to 37 seconds. If you guys have any questions, maybe after that, come see me in the booth, or we have to wrap it up, right? Thank you. Thanks for coming.